52 is a little bit harder because now we have a 5-membered ring and we're used to seeing 6-membered rings as the product of Diels-Alder reactions. So we know we're not going to start out with the Diels-Alder reaction to begin with. What we do see is a 1,3 positioning of an aldehyde and an alcohol, which actually can be a pretty good indicator for us that we have an aldol condensation where we have a new bond being formed between this carbon and this carbon. This carbon then would be the enolate that ends up adding on to an aldehyde over here through an intramolecular aldol condensation. So when we think about this backwards, we have a 6-carbon chain with aldehydes at the 1 and 6 positions. 1, 2, 3, 4, 5, 6. We can go from this 6-carbon chain to this if we use sodium hydroxide to form an enolate by removing a proton here and making an enolate, or here, it doesn't matter, they're identical. And then we probably not want to add heat actually, because we end up with alcohol rather than the alkene based product. If we want to go from here, we know that we can make this cyclohexene. That's something that we've done in the previous 2 parts of this question. And we can go from here using one of our oxidative cleavage methods. We could either use osmium tetroxide and peroxide and then oxidatively cleave with periodic acid, or we can use ozonolysis in order to get here as well. I'm going to use ozonolysis because it's a little bit greener. So we'd use O3 in the first step, and then we'd use some sort of reducing agent. Zinc and acetic acid is usually what I use. This is acetic acid, ACOH is the same as this. And when we use these conditions, it gets us to this. When we use sodium hydroxide, it recondenses like this.